Assalamualaikum. My name is Nura Atika binti Muhammad Kamil. I'm going to give an explanation about Lab 5, which is a path loss model analysis. In this lab, the objective to aim in this lab is to write a MATLAB program for the path loss analysis, and secondly is to determine the free space loss and also the power received. So, as a theoretical, we know path loss is a reduction in power density, which is an attenuation of an electromagnetic wave as it propagates through space. So, from a theoretical part, free space path loss calculation has been given in decibel version, and also calculation of power received in dB version. So, for a simulation part, we need to give an analysis of free path loss analysis based on a different frequency, distance, and also the power received and also the power transmit. So, for example, this is a coding simulation, coding for a path loss analysis. So, I'm gonna run this coding. For example number 2, which is the frequency is 2000, and it will give the wavelength of that frequency, and the distance is 100, and the gain transmit is 5, and the gain receive is 7, and the power transmit is 10 dB. So based on this simulation of MATLAB coding, we can automatically find the free path loss in dB. Secondly, we can find the received power in dB, and thirdly, we can find the value of received power in watt. That's all. I'm gonna pass to my friends to continue for the explanation. Thank you.
I'm Nushafiqah binti Mak Yazid. I will explain question and the discussion part. From question 1, need to comparison from step 1 and step 2. So what happened to the output when you modify the frequency value? So from table 4.2, when increase the value of frequency from 1000 MHz to 2000 MHz, the result at path loss is increased. Then the received power value is decreased from 9.03 to 2.25. So comparison of step 3 and 4, when the distance change from 100 km to 250 km, it influences a result at received power Rx decrease. Then the loss power value increase from 1.32 dB to 1.4 dB. And last, comparison step 5 and 6. By comparing different power transmit of step 5 and 6, which 10 dB and 20 dB at the same time, frequency and the distance result at loss maintained with 1.32, but the power received is decreased. For the question 2, we need to compare test result to MATLAB. So this is MATLAB result. We got the path loss is 1.32 dB. The Rx is negative 1.10, and the Rx is 9.03. So based on the calculation simulation result from MATLAB, result show same value for both path loss and the received power in dB. So from this discussion, the different distance between transmitter and receiver also may due to the path loss. Based on this lab report, it show that a frequency distance may have influenced the value of path loss and received power. It proved in question 1 and 2. Then, but when the power change at the same frequency, the distance only the path loss value show a different while received power value maintained.
At the end of this lab experiment, you are able to write a MATLAB program for path loss analysis. The free space path loss is the loss in signal strength that occurs when an electromagnetic wave travels over a line-side path in free space. Apart from that, we are also able to determine the free space loss and the power received. Referring to the result and analysis, we managed to cover these two objectives and obtain the successful simulation result.